Well, hello there. We're working on section 8.5. Um, really, we're just focusing on rotations in the coordinate plane. So, rotations, I can picture a rotation, or I can think about the rotation of the Earth, how it spins on its axis. But we're going to talk about rotations in a coordinate plane today. So, our goal to focus on is I can rotate points and shapes in the coordinate plane. So, let's start off. What actually is a rotation? Well, Buzz Lightyear to the rescue! A rotation is typically defined as turning something around a center point or a center axis. But when we're dealing with a coordinate plane, we're going to talk about rotating around the origin. That would be the point 0, 0, the very middle of a coordinate plane. So we're going to rotate or turn something around that point. Some key notes about rotating points in the coordinate plane. How do you do it? Well, there's a couple things you got to know. First one is we rotate around the origin, like I just mentioned. We're going to rotate around that center point. Um, Second thing, we're going to always rotate counterclockwise. Unless you're told otherwise, you typically rotate counterclockwise. That means if you're looking at a picture, thinking of a clock, this would be the coordinate plane. You're going to rotate this way, around to the left. All right? That would be rotating counterclockwise. Make sure you're following the rules for rotating. There are rules that we're going to talk about that you'll learn in just a little bit. The rules for rotating will tell you the easiest way to find where the new point will be. And use a graph. Always use a graph to visual check it to make sure that that made sense. That you can picture going around a coordinate plane. So for instance, if you have a point that would be right here on the 6 on this x-axis, and you wanted to rotate it 90 degrees. Remember, we're going counterclockwise, and a 90-degree turn would form a 90-degree angle. So it's going to go right up here at the 6, and it would form this 90-degree angle. If you want to go a full 180, you'd go all the way over here. 270 would be down to here, and 360 would be back to the original. Okay, so that's just a visual way to picture rotations. Now, let's actually come up with the rules for rotation, so we can do it without we can do it to find, like, let's just give you a point 1, 2. How do you know what the point is if it's rotated 90 degrees? That's hard to picture because it's not right on the x or the y axis. So I found this pretty cool site where you can rotate. You can pick a point and you can just rotate around it. So look at this graph here. I'm going to rotate point 1, 2 about the origin. I want to do 270, so I want to change the rotation to 90 degrees. Okay, so here's the point 1, 2. Over 1, up 2. There's your point 1, 2. And I'm going to, we'll leave the speed how it is, and we're going to rotate the whole thing 90 degrees counterclockwise. There it is. And the point is -1, or -2, 1. So it actually does form a 90-degree angle if you look at that. But -2, 1 would be right there. Let's put that in here. All right. Next one, let's try 180 degrees. We'll start over. Let's do the same point 180 degrees. There it is. -1, -2. So that makes a 180-degree angle between those two. -1, -2. Interesting. All right, so let's now try 270 before we move on here. There it is. 2, -1. Like music? Well, anyway, 2, -1. And let's just, for the sake of figuring out a 360-degree rotation, we're going to do the same thing, 360. I'm going to up the speed so it goes really fast. Apparently I can't go faster than 7. So let's do it. There we go. All right. It goes right back onto the original. When you do a 360 rotation, you just go all the way around. So you'd end up with 1, 2. So if you look at these, you can kind of, maybe you can see from the original to the 90-degree angle, see if you can see the comparison. There is actually a pattern that would happen for every 90-degree angle, every 180-degree angle, every 270, and then 360 obviously is the same. So to infinity and beyond. I bet you didn't see that one coming, huh? So, just like that, Buzz Lightyear is gone, and now we have all of these filled in for all of these points. So I did it on my own there for you so you can see it. So you can see the -3, -4, that point for a 90-degree angle went to 4, -3. The 180 went to 3, 4, -4, 3, and then the 360 was the same as the original. You can look at the same thing for the other 2 points that are there. And if you look at it hard, see if you can figure out what possibly the pattern is. So every 90-degree angle, so we went from 1, 2 to -2, 1. So it looks like they switched. So we took our ordered pattern, we switched the x and the y. I'll actually move this over a little bit. And I wrote YY, so that was weird. Switched the x and y. So originally it was just ordered pair XY. Switched them, and every time they switched them, and it looks like they made the new x value the opposite sign. Yep, because this would have been -2 and they made it a +2. This would have been -4 and they made it a +4. It would have been +2, they made it a -2. So this first one is the opposite. I feel like the 180, that one's a little bit easier. It looks like 1, 2 to -1, -2. -3, -4 to +3, +4. +1, -2 to -1, +2. So it's just switching the sign on all of them. So you're keeping the x where it is, you're just making it an opposite. Keeping the y where it is, you're just making it an opposite. 270 is a little bit trickier. It's similar to 90 degree because they're switching again. You put the original y in the back, in the front, and the original x in the back. Those are switching, but it is the second number that is being the opposite. So from 1, 2 to 2, -1. So this is the one that's becoming the opposite. And then finally, 360 is the same as the original xy. All right, so make sure you have those rules written down, these rules right here. And we're going to do this on a couple of problems. So, example 1, given the coordinate, given the coordinate of D, which is -2, -4 give the coordinate of D after a 270-degree rotation about the origin. So 270, we switch them and we make the second number now the opposite, the new y value the opposite. So I'm going to switch them. I'm going to say this is going to be D prime. Our new one is D prime. I'm going to switch them. I'm going to put -4 in front and -2 in back. But we also said we make the second one the opposite sign. So I'm going to get rid of that negative. And it becomes -4, +2. That's it. That would be your point after a 270-degree rotation. How about this next one? How about a 180? It says give the coordinate of -4, 5 after a 180-degree rotation about the origin. So 180, if you recall, we just switched the two signs. So xy 180 would be -x, -y. So you switch the signs. So d prime for this one would be +4, we're switching the sign, and then -5. All right. And lastly, example 3. It says rotate. You want to do a rotation 90 degrees counterclockwise about the origin. So now we have 3 ordered pairs. We have S, we have B, and we have L. I'm going to write those out so we know what we're doing here. And S is 2, 2. B is 1, 2, 3, 4, 1, 2, 3, 4, 5. So 4, 5. And C is 1, 2, 3, 4, 5, and 0 up. So 5, 0. 90 degrees, if we look back, our rule is to switch the x and the y, and then the new x value is going to be the opposite sign. So for this one, let's do S prime. Switch the x and the y, so 2, 2, that doesn't change anything. But the new x value becomes the opposite. B prime. Switch the x and the y, 5, 4, and the new x value becomes opposite, so it's -5, 4. C prime. Switch the x and the y, but a negative of 0 is still 0, so it's just 0, 5. So let's plot those points. S prime is negative 2, 2. Negative 1, 2, negative 2. So there's S prime. Negative 5, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. That would be B prime. And then C prime is 0, 5. 0 up. Wait, 0 over 5 up. 1, 2, 3, 4, 5. That would be C prime. Whoops. And now our new shape looks like this. Same shape. It is just rotated. You can kind of see it's rotated like this. This one was right there. Now it's right there. So it's rotated 90 degrees. All right. So that's how you do rotations. Those are the rules. Please make sure those are ingrained into your mind, or at least written down so you can utilize them. Um, and that is rotations in the coordinate plane. That's the basics of rotations right here. So review that goal of I can rotate points and shapes in the coordinate plane. Have a great day.